Okay, so start. So today we'll start with the new topic, which is equations of motions. This is a mathematics which will help you understand the motion of the object. And in this case, in all the equation which I am going to discuss today, the motion is a uniformly motion, right? So these equations, they are valid only when the object is doing uniform acceleration, right? If acceleration is not uniform, then these equations, they are not valid. Okay, so equations of motions, they are valid, or they can be applied when motion of the object is uniform. Motion is uniformly accelerated. Uniformly accelerated. For non-uniform motion, it cannot be used. Uniformly accelerated. Uniformly accelerated means acceleration is constant during the motion. So A is constant. A that remains constant during the motion. If we have this type of situation, any object, Mario, pay attention. If we have a situation, an object is moving with a uniform acceleration from one point to another point, from a starting point to the destination point. So in that case, we can use these equations of motions, right? So now I'm going to write the equations of motion. V is equal to U plus A into T, where V that is the final velocity of the object. You can say final velocity, or you can say final speed, right? Or you can say final speed. Okay? Final U is known as initial speed, when the object begins from a starting point, right? When the object starts its journey. So you can say initial speed, or you can say initial velocity, same thing. Okay, initial speed, or you can say initial velocity. And what is this A? A is acceleration, right? And uniform acceleration. So what is A? It is uniform acceleration. Uniform acceleration, or you can say constant acceleration, right? Constant acceleration between the starting point and the end point, between the starting point and the destination point. So you can say uniform acceleration, or you can say constant acceleration. Okay, so this is my first equation of motion, and time, it is a time taken by the object, or time taken by any moving thing from starting point to the destination point. So time taken between the 2 points. Time taken between the 2 points. The starting points and the end point. The starting point and the destination point, right? First equation of motion. Second equation of motion, that is V square is equal to U square plus 2AS. Again, what is V? Same, final speed or final velocity. U moving a random path, then you can use the distance, right? Now third equation of motion, S is equal to UT plus half AT square. Again, what is S? S, it can be the distance, or it can be the displacement between the starting point or the end point. Again, U is the initial speed, A is the acceleration, right, and T is the time, right? So from equation 1 or 2 or 3, you see this A is important for us, right? If this A is constant during the journey, then these equations are quite valid, right? And you can use these equations of motion in a free fall situation also. Free fall means when you drop something at some height from the surface of Earth, then that object also comes down with a constant acceleration 9.8 meter per second square, right? So these equations are valid in free fall also. In free fall. Free fall means when we have A is equal to constant and that is equal to 9.8 meter per second square, right? So in the free fall also, when something comes down, we drop from certain height above the earth and that comes down with this acceleration 9.8 meter per second square, then we can use these equations. Okay. So fourth equation, that is average speed, right? So average speed of an object that is equal to final speed plus initial speed divided by 2. That is the average speed. Final speed plus initial speed divided by 2. Okay. So our main focus is on these three equations 1, 2 and 3. So let us take one situation, one example, right? One example. We have a Formula 1 car. This is F1 car, right? And you know the Formula 1 car that moves with a very high speed, right? So maximum 230 or 225 RPM, right? With that much of RPM. Okay. So here we are given, we have a Formula 1 car, and that starts from a point and then start moving with a constant acceleration A is equal to 18 meter per second square, right? The car, Formula 1 car, that is moving with acceleration 18 meter per second square. Okay, so we have to calculate its speed after 3 seconds. Okay, after 3 seconds, what is its speed? So now which equation we can use? Which equation? We can use first equation. Okay, by using the first equation we can find out the speed. So if I apply first equation of motion, which is V is equal to U plus AT, right? So I can find out the speed after 3 seconds. So when the Formula 1 car starts, so its initial speed was 0. Okay, U is 0, right? Because it starts from rest, so its initial speed is 0. So now I can take V is equal to, A is given 18 meter per second square, time is given 3 seconds, right? So second cancel, so V is equal to 54 meter per second. So the Formula 1 car was moving with a speed 54 meter per second after 3 seconds. Okay, after 3 seconds it was moving with a speed 54 meter per second if the acceleration is this. Now the question is, what is the nature of this speed? What is the nature? Which type of speed is this? This is the average speed or this is the instantaneous speed, right? So keep in mind all the time, if we are asked to calculate speed at certain time, then that is the instantaneous speed. Okay, so this speed This is known as instantaneous because this speed is at 3 seconds, right? When the 3 seconds are there, then this is the speed. So this is known as instantaneous. Instantaneous speed, right? Equation of motion you will use to calculate. Which equation of motion you will use? Yes, which equation of motion we will use to calculate the distance? You see this equation of motion, right? We can use to calculate the distance. So again, using equation of motion, S is equal to ut plus half at square. Again, this term is 0, right? Because the object starts from the initial point where the speed was 0. So this is 0. So the distance traveled, that will be equal to half. Acceleration is 18. T means 3 square 9. Okay. So this is S is equal to 81 meter. So distance traveled in 3 seconds is 81 meter. Okay. One more thing we can calculate. So now we have to find out what is the velocity when this car travel a distance of 200 meter. Okay, so the car is moving with this much of acceleration. Okay, and the question is when the car travel 200 meter, what was speed that time, right? So question number 3, speed of the car when it traveled 200 meter. We have to find out the speed when it traveled 200 meter. So the moment the 200 meters are gone, what is the speed, right? So which equation of motion we will use? The second equation of motion we can use, right? Because we are given 200 meter distance. We are given A. Okay. So now we can find out the speed. So now again applying the equation of motion, V square is equal to U square plus 2AS. U is again 0 because the car starts from the starting point, right? So initially the speed was 0. So V square is equal to 2AS. Or you can say V is equal to, this is square root, this will become square root, 2AS, right? So now we can solve. 2A is 18 meter per second square and this is 200. Okay, so this becomes V is equal to square root 7200 and this is meter per second. Okay, and as I take the square root of 7200, this will around 80 to 84. 84. Okay, so this will be nearly 84 meter per second. Okay, so you see by equations of motion we can solve the question of this type. Right? Or directly, if you are asked to find acceleration, right? So let me give you one situation. We have a point A and a point B, right? We have two cities, right? Suppose this is one city A and city B. So something that start from here, right? Start from here. And finally, when it crosses B, its speed, the final speed, that is 100 meter per second. And when it crosses point B, right, from point A, the total time it takes 10 seconds. 10 seconds. So find out the acceleration. Okay? Calculate the acceleration. So calculate A. Calculate acceleration. So again, by using equation of motion, we can solve this question. So use first equation of motion. V is equal to u plus at. So V is equal to u plus a into t. U is 0 because the object starts from point A, right? So we'll take u is equal to 0. So V will be equal to a into t, and we are asked to find a. So a will be equal to v upon t. V is 100 meter per second, time is 10 seconds, so acceleration is equal to 10 meter per second square. So it means the object started from A and it was moving with acceleration 10 meter per second square. When it crosses point B, this was the acceleration. So you can say this is the acceleration at point B, right? Why? Because we took 10 seconds at B. Okay, 10 seconds was here, then 9, 8, okay, 0. So actually this is the acceleration at B. So when this is the acceleration at B, so it means this is instantaneous acceleration. Okay, acceleration at B, so this becomes instantaneous acceleration. This is at when we calculate speed, velocity or acceleration at a time, at one particular instant of time, then that becomes instantaneous speed or instantaneous acceleration. So here we are calculating, because V is right 100 meter at B and the 10 second is, so this is a free fall. Free fall means on the surface of Earth the acceleration is 9.8 and this is around 2 meter height above the surface of Earth. So at 2 meter again the acceleration is 9.8. So it means when this cap comes down, it means at this point the acceleration was 9.8, here also 9.8, here also 9.8, till it touched the ground, acceleration is same. So it means the motion of the cap is under a constant acceleration. And I told you that when the motion of the object, big or small, right, in that case we can use the equations of motion. So I have a question for you. This is Earth, okay, or you can say this is ground. This is ground, and at a height h, okay, we have a ball, and I drop this ball from this point, and this height is given. This height is equal to 100 meter. Okay, the height is 100 meter, and you have to calculate the final speed of the ball when it hit the earth, when it hit the ground. Okay, so when this ball hit the ground, when the ball touched the ground, when the ball hit the ground, what was the final speed? So at this point you have to calculate V final. Okay, so U is 0 because from rest at height h it was in rest. Okay, suppose this is the cap, so at this point the cap is at rest. So initial speed of the cap is 0 and the final speed of the cap when it hit the ground is Vf. So now you calculate Vf. How you will calculate Vf? You are not given the time. Time is not given. How you can calculate? So apply this equation of motion, right? This is a very frequently used equation when we are dealing with the question of free fall. Okay, so use this equation. So V square is equal to U square plus 2AF, right? So V square is equal to U square plus 2AS. Initial speed is 0. So V square is equal to 2AS. So V is equal to square root 2AS. So V is equal to square root 2. What is A? 9.8 meter per second square. That is acceleration due to gravity. So the ball comes down and the acceleration due to gravity, the value of G is 9.8 meter per second square. Right? At this point 9.8, at every point during its journey till finally it hit the ground, the acceleration remains same. So I will use 9.8, right? 9.8. And what is S? S is the height. So I can replace this as H. I can replace this as H. Okay, this can be replaced by H. So H is square root, this is 100 meter. Now rest is the mathematics, right? SI 2 times 9.8 times 100. This is 44.29. Okay, 44.29. 44.29 meter per second. So this is the final speed, V final. So V final, when finally the ball or the cap hit the ground, so hitting speed was 44.29 meter per second. Okay. Now if we modify this question, right? If we modify this question, now we have the final speed, right? We have the initial speed, we have the acceleration. Now tell me how much time the ball took to touch the ground. Now you calculate the time. Okay? So second is calculate time. Calculate time. How much time this ball took from the starting point to the surface. You can calculate the time also. Okay? So now again you can use the first equation of motion. V is equal to U plus A into T, right? So now initial speed is 0, V is equal to A into T, so T will be equal to V by A, and V is 44.29, and A is 9.8, SI, 44.29 divided by 9.8. 44.29 divided by 9.8. 4.4. 4.5 second. So 4.5 seconds. So time taken from H is equal to 100 meter to the ground. So T is equal to 4.5 second. Okay, within this time, under the constant acceleration, it will hit the ground with a speed 44.29 meter per second. Right? So these equations of motions, they are valid when something is moving on the ground, something is moving on the road, something is moving over the surface, or something is falling over the surface. Right? Okay, Mr.